we threw the switch. At 5 minutes after 4, we are now running the house off to the NHX-10. So we're gonna let it do its normal thing. We're gonna see how things are going. We've got Solar Assistant up and running so we can see what loads are doing. Right now we're at, as you can see on screen, 440 watts. Let's see how it works as we go into the evening. How does it handle the loads? Do we see light flicker? This is running everything that my normal system would run. And how does it work? So I'll check in at various times throughout the night. Let's see how she does. Well, this is going to be my only update for the evening. I was planning on doing some more, but about an hour after I started the test, I got an emergency call. I had to go to my grandpa's house due to some flooding, and that flooding was actually kind of a blessing from God because a torrential storm came through during the time that I was there, which revealed backed up gutters and other flooding points, and so I was able to get all that stuff taken care of while I was there, but it meant that I got soaked. I was out in the hailstorm, out in the downpour rain and all that stuff. But anyways, I was gone all the evening, got home. It is now 10 minutes to 10. Got home, took a shower, walked into the kitchen, turned the light on, tried to see if I was going to see any flickering, and I didn't see any light flickering in the kitchen. I even set the dimmer back down to that 50% range. No flickering. When I was in the shower, I really didn't notice that usual blink that you see when a large load kicks on when running off of an inverter. Maybe I missed it. Maybe my eyes were closed, when that blink happened. Maybe it's due to the fact that it's a hybrid inverter and the grid is on all the time, and so it uses the grid for those surges. I don't know. It's something I'm going to have to keep an eye on. But right now, if we take a look at Solar Assistant, we're pulling almost 7,000 watts out of the battery. So we've got the water heater running. It sounds like the dehumidifier is running, some other lights in the house because it's evening time, some ceiling fans. So yeah, almost 7,000 watts out of the battery. And so far, no problems. I mean, when I was at my grandpa's house, I didn't get any frantic phone calls from my wife saying lights were blinking, flickering, there were any power problems. Everything just worked. If we scroll down to the charts, I had Ian run the dishwasher just as I was getting ready to leave, and that was 5.5 thousand watts. I would almost say that even 3,000 watts on this inverter is really nothing to speak of. So it wasn't until I got home and jumped into the shower. There's our, 7,000 watt load. But, I mean, everything's running great. With the inverter running, 6,500 watts. I'm about the same distance that I was before, and we're looking at about 42 decibels with those fans running. I mean, you got all 4 fans running. I feel air movement. It's not hot. But all in all, I mean, so far, in the last, 5 hours, things have been running fine. I knew evening time was going to be the time that really we were going to see what this thing's made of. So we'll let it run through the night, and we'll come back and take a look at Solar Assistant, look at the log from the overnight hours in the morning. I am still running this in zero export mode because I want to mimic my current environments that I've been testing in. So it's zero export mode. I still have it set to 8,000 watt limit, so anything over 8,000 watts, which is the default value, that's when it's going to pull from the grid. So we'll see how things run overnight. Well, good morning. I didn't lose power last night. We jump on over to Solar Assistant to take a look and see what happened. We can see that just after 8 o'clock this morning, it looks like we ended up, oh no, it looks like it was actually earlier than that, maybe around 6 o'clock. We ended up switching over to grid. We really didn't have anything of note. There's the water heater kicking in to top things off right around 3:30 in the morning. Looks like we also had it warm up around midnight. And then I know Between 10 and 11 last night, we ended up starting the dishwasher again. And then just normal fluctuations of loads throughout the night. So this test is turning out to be pretty boring. So I think when I get home from my meeting this morning, I'm gonna have to go through and kick it up a notch. Let's see if we can load this thing down and make this thing actually do some work. Actually make this somewhat of an enjoyable video to watch, other than just, yeah, it works. All right, so it's just after 1 o'clock looking at Solar Assistant. We've got, what, 2,700 watts coming out of the battery. I did turn the sink on upstairs so we could get some hot water running, get the well pump going, see if we can do some pushing of this system. So it just bumped up. We're at 7.2 kilowatts. And I've got the bounce house blower to see what happens. This is still grid connected, so we're gonna see. In fact, something's clicking over here right now. It just switched over to grid for some reason. I wonder if we went over the battery threshold for the power out of the battery, 8,000 watts, which we might have. Nope, fans are spinning back up now. It's a fairly seamless transition back and forth, which is kind of nice. 7.2 kilowatts load. All right, let's add the bounce house blower and just see what happens. 7.2 kilowatt load right now. Add the blower. It says we've got a grid overload. We're pulling 1.5 from the grid. 9 kilowatt load, 8 kilowatts out of the battery. Maybe that's the time of use warning. Let's see, it's after 1 o'clock. $4,000 watts on leg 2, 3,000 on leg 1, almost 5,000 on leg 2. But everything seems to be running. I just heard a click. Oh, that was the well pump turning off. And our overload went away on the front of the inverter. But we're down to 7,500 watts out of the battery right now. That's a big blower though. Pretty sweet. And if I came in here and said, well, I only want it to use 5,000 watts out of the battery, I can hit OK and save it. And now we see 5,000 watts coming out of the battery, 1,000 watts coming from the grid right now. We can see that on Solar Assistant as well. Set it back to 8,000 where it's defaulting. You watch our grid drop back down. Should I add another load? Why not? So now our load is 9,800 watts. We are pulling from the grid. So in a grid mode, that's kind of nice. It does say grid overload on the screen. We're pulling 800 and so watts from there. But now I'm kind of curious as to how this is going to work when there is no grid. So we'll pull our plugs on our 2 big loads. And I want to turn off the grid and just see how the inverter works on its own when there's no grid backup. So there goes our grid connection. Voltage is dropping down to minimal voltage for grid. So we do have a 6.6 kilowatt load right now. We do have some coming from solar, which is fine. So now, yellow cord is blower and gray cord is vacuum. It does sound like my dehumidifier is running over here too. So let's add the bounce house. Vacuum. $9,500, 173 amps coming out of the battery, 5,000 on leg 2, 4,500 on leg 1. This is fun. Fans are going on this thing, but you kind of expect it running max load. Much better test than what we were running, just running the house, because it's boring. So if I recap, let's see, we've got some ceiling fans running through the house, we've got the water heater running, we've got the dehumidifier, a bounce house blower, a vacuum cleaner. I'm sure the well's gonna kick in at some point in time. Lots of load. And we've got the grid turned off. All right, pull those. We're still fairly balanced from output power. The well just kicked on. Oh, nope, the well just kicked off. So that dropped it. So let me see if I can add some load on one leg and push one leg up. All right, so I added the vacuum to leg 2. Now what happens if I add the bounce house blower to leg 2? So it makes some noise coming from this inverter, like it's when that blower spools up, like it's really trying. But it eventually does spin and fire. So looking at solar resistant, 8,045 watts. Looking at the screen, 5,300 watts on leg 2, 2,600 on leg 1. And everything just turned off. I'm assuming it was because the overload on leg 2. Fans are still going on the inverter. Overload, okay. So yeah, A02 overload. So yeah, you kind of expect it. I mean, it was running for, I don't know how long it was running for. Check whether the load is compliance. Yeah, cut off all power, shut down all the machines, disconnect the load, and plug in to restart the machine. So I don't believe this has an auto restart on this inverter. I think you actually have to turn it off and then turn it back on. All right, let's turn this off. Click it back on. And I'm just pressing the RSD button on the side of the inverter to let it turn off and then turn back on. And then it takes a second or two for it to kind of wake up, I guess. I wonder if it has to completely shut down, because it doesn't seem to want to be resetting. So let's turn off PV. Turn off the inverter. Screen went out. Now if I turn the RSD back on, what happens? Now turn the PV back on. So it does seem to need a full shutdown. Fans are spinning back up. Well, it doesn't like that. Inverter short. So I heard the vacuum start to spin up. So I unplugged that. A36. Fan faults. Check where the inverter temperature is abnormal. Check whether the fans run properly. Yeah, the fans are running fine. At least they were. So let's turn it off again. I forgot, when this thing's in standby mode and it has battery power coming to it, it'll turn itself back on, so to speak, in that standby mode, which is why the screen came back on. It's detecting battery power. It's not doing anything. It's in standby mode, but I forgot that it'll do that. So let's turn on the RSD again, because as soon as it turns on and starts putting power out, I'm sure the water heater is going to want power. Fans are spinning up. And we've got instant power requirement from, so it had to have been something with the surge trying to start up all that power. What, 8,000 some watts right off the bat, which is kind of my fault, but still a cool test. Turn PV back on. And I'm gonna go turn the sink off. Now I have noticed, if we look at the screen here, so I turn the PV back on, but there's occasional times where it doesn't start pulling anything from PV. So the whole system just powered down and rebooted, and I turned on PV, the PV switch on the side. It is like 80 degrees outside and sunny. Sun's hitting those panels directly, and we're not pulling any power in. The well just kicked off, so power dropped down. So the water heater should be really the only big load. I do see that the dehumidifier is still running. We don't have grid. All right, there, now PV's starting to, we got 900 watts of PV, now we're at 1400, so now it's starting to come in. So let me turn my grid connection back on. It shouldn't really do anything other than when it detects the grid, it should just sync with the grid so that it can be in its hybrid mode. So it says grid voltage low as it's detecting grid power coming in. So 122 volts on each leg, 1.4 kilowatts. So, well, that test, oh, and I think I heard things click. So it just switched, or it just connected the grid relay into the system. So I think my UPS clicks when that happens. Kind of a little hint. Now PV did go away, and it's pulling 3 kilowatts from the grid right now. It's going down, and now grid is starting to ramp back up. It's got to be something with a synchronization process. I mean, it is a hybrid inverter, so it's got to synchronize what frequency and everything so that it can seamlessly utilize either power from battery or grid and mix them together. I think that's how that works. So, but you kind of saw on the screen how that worked. That's kind of neat. So this test ended up drastically changing because the whole 24-hour run the house test was extremely boring. The lights in the kitchen didn't flicker when I saw them last night. The bathroom lights when I was taking a shower, I didn't really even notice when the loads kicked in. We added some loads to it. We ran it up to 9,600, 9,700 watts of load. We had the grid tied together, and we saw it pull from the grid when it got over that 8,000 watts. We increased that output, and it still shifted everything back properly. And then I disconnected the grid. We saw it still handling those loads fine. On top of the well and the water heater running already, we added those 2 inductive loads to a single leg and watched it go over that 5,000 watt limit. And it ran it for was it maybe 30 seconds? Some fun tests. I thought I killed the thing. I swear, I thought I killed this inverter. I'm like, oh no. Because when it didn't turn back on, because I didn't think about the fact that it was going to try and do the water heater and the vacuum at the same time, and that was going to be, 8,000 watt surge right out of the gate. It did not like that at all. So yeah. But once I dropped that down, which if you think about it, you really don't want to do a surge load to start these things up right out of the gate like that anyways. Let it wake up. But cool. Well, that was fun. Fun pushing this thing right to the edge and then pushing it over. And I would imagine that had I had the grid connected, it would have helped with the surge right out of the gate. It does make, when it's got some of those really hard surge startups, it makes a little crackly noise coming from the inverter. You probably can't pick it up on the microphone. I hear it when I try and do that bounce house blower. And then when we had, 8,000, 8,500 watts right on startup, I heard it do that as well. That's when it threw that fan fault. But as soon as the surge passes, and again, that's battery only, as soon as that surge passes, then it's like, okay, I'm ready to go. So I'm gonna let this thing run for, I don't know, let's let it run for a week or so and just see how well it does. Let it do its thing. I want my wife to tell me that she doesn't even notice that we're not on grid. So with that, I think I'm gonna let you go. Y'all stay safe, stay cool. Boy, it's gonna be a hot one today. Catch up with you later.